Assalamu alaikum and hello everyone. This is Group I from Engineering Statistics doing the assignment of tablet pill number I. Our team members are the following. Uh, Abdullah will be presenting part A. I, Omar Amgad, will be presenting part B. Muhammad will be presenting part C. And Ibrahim will be presenting part D.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Abdullah Barak Muhammad bin Bashir. In this assignment, I'm going to explain the part A, which is about the summarize and describe the symbol data. So this table has 200 symbols, and we have 4 variables. So for the first variable was the weight. So I summarize based on the firstly based on the count of the weight, the shift. So in the evening, we have 78, which is the highest, and the morning 57, and the night is 65, which is in the morning, which is the lowest one. So then we calculate the sum of the weight, average of the weight, variance, and the standard deviation. As you can see, in the evening is the highest one, which is 27,000. And for the average, the morning has the highest number, and for the variance and for the variance and the standard deviation, the night shifts has the highest values. So, and this diagram describe all these numbers. So I use the frequency distribution to count the weight based on the interval, which is 10. So the gap between is 10, and if you see here 60 weight shift, it's equal between 345 and 355, as you see here in the diagram. And these are the important values. I just gathering them in one box. So for summarize, based on the relative density, the count of the relative will be the same for the weight, and the sum of the relative density for the evening is the highest number, and for average also the evening has the highest number, and for the variance and the standard deviation, the morning has the highest values for the variance and the standard deviation. And here is the total for each of them. And this diagram describe all these numbers. Also, I have used the frequency distribution to count the relative density. As you see here, from 88 to 89, this has the highest counts of relative density, and this table is described the important values. For the summarized based on that tensile strength, the count of tensile strength will be the same, and for the sum of the tensile strength, the evening has the highest, and for the average also has the highest, and for the variance and the standard deviation, the morning has the highest values. And this diagram describe all these numbers, and I use the distribution to count the shifts between the range, which is from 7.1 to 7.2, has the highest shifts, which is considered as 44. So this table is describe all the important values. And so now, thank you for listening.
Hello, this is Omar Amgad here presenting part B. In part B, we are checking whether the production is following the FDA requirements. The requirements given by the FDA are the following: a normal distribution and an average weight production of 350 milligram and a standard deviation of 14 milligram. So we do so by doing the GOF test. which I will show now in Excel. In summary, the production of December 2020 follows the FDA requirements with a 95% confidence. As we can see here, this is our data. So we first specify the requirements by the FDA, and then we produce the pivot table to produce several categories with an interval of 10 milligrams, and then we calculate the probability of each category, as we can see here in this column M, and then we calculate the expected values that that the distribution should follow. If mathematically speaking, we should not have any expected value less than 5, so we combine categories as we can see here. So 15 is 12 and 3, same goes here. And after that, we compare the observed and expected values using the chi-test formula, and which is the sum of OI minus EI squared divided by EI, and the sum is 2.8, with a p and the p-value should be 0.72. So after that, the third step should be, after we have calculated the test statistics, we measure the chi-square value that we will compare with 2.817. So we specified the confidence of 5%, which results in 11.0705. And we compare. So we have two ways of comparing. We either compare by the p-value, aka the probability, or the chi-squared value, the value associated with the distribution. So with both methods, we can see that the result is that we are accepting H naught. H naught, as we specified earlier, is that the weight is normally distributed, meaning that since the data is normally distributed and is following the FDA requirements, it means that the production data follows the FDA requirements. So that's it for FDA part B, and now we will go to part C.
Hello, my name is Muhammad Tamim Bakro. I'm from Group 9, and today I'm going to explain to you Part C, which is to comment on whether there is any significant difference between the tablet weights from the different shafts. So now I'll explain everything in details through the Excel sheet. Okay, so this is the Excel sheet, and here's on the left the weights of the shafts in the morning, evening, and night. As you can see over here, this is all the weights in the 3 shafts, and then the alpha is equal to 0.05. H1 says that there's no significant difference between tablet weight from the different shafts. H1, there's a significant difference between the tablet weight from different shafts. So this is what we claim. H naught is equal to mu1 equal mu2 equal mu3, and H1 mu I is not equal to mu j for at least one I not equal to j. So in this we can consider that the B value is greater than alpha, then we accept. B value is less than alpha, then we reject. So this is the ANOVA single factor and the summary table over here. and showing the morning, evening, night shifts, the count, the sum, and the average. And this is the ANOVA other summary. So the conclusion for this, that for the output p-value, which is equal to 0.7431, suppose we chose alpha 0.05. Noticeably that the p-value is greater than 0.05, then we fail to reject the H naught, and we conclude that there's no significant difference between the tablet.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Ibrahim Hassan. So for regression analysis, firstly we use the Microsoft Excel data analysis to find the coefficient, which we will use later in the equation for the regression. So here we got the coefficient, which is alpha is the intercept, so it is this value, and beta, which is the slope, and then we substitute the values to the equation to get this final equation. Then we substitute the values of x and y, while x is the independent value, which is relative density, and y is the dependent value, which is tensile strength. And finally you got the graphs of the line fit plot and residual plot, which shows that there is a strong linear relationship between x and y, which is relative density and tensile strength. And for the validity, this linear regression model is valid, so we can predict the tensile strength based on the relative density of the pair. Thank you.